Question number 3 now of Winter 24 paper 4-1. So this question is about linked list implementation, and first of all we'll visualize the problem to get a better idea. So they're saying that there is going to be a linked list which will have 20 nodes, and then the linked list will have two columns. There would be one dimension which will store the data, and the other dimension or the other column will store the pointer to the next node. So this is some dummy data here. So let's say we start from 0. So the data would be 100 and the next is 2. So 2 means we go to index 2, row 2. So this is data 60 and the next is 3. So we go to 3. 99, then next is 1. So we go to 44, 4, and next is 4. So we go to 4 and then the next is -1, which means that this is the end of the linked list. There would always be a start pointer, and then there would always be going to be a first empty, which is going to store the index of the first element in the empty list, which is the part of the list that is still empty. This is the first node in the empty linked list, which is initialized, and the index is 0. So they're saying write program code for the main program and declare initialize linked list first node and first empty. Okay. So we have to first initialize the linked list. So linked list would be initially empty, and yep, and then we'll have the first node which is set to minus, and then we have the first empty which is set to 0 as per the question statement. Then they're saying that all the data values would be -1, and then all the pointers would be current value plus 1. So if the index is 0, so it would be 1, then index is 1, it becomes 2, so on and so forth. So we'll just add 1 in the current loop variable value. So for I in range of 20, because there are 20 values here, so we'll say, in fact we won't go till 20 because the last value is supposed to have both -1s. So this will do manually. So we'll go from 0 to 18, and 19th would be the last index. From 0 to 19, that would be 20 values. So we'll say linked list dot append. Okay, and we're going to append. So they're saying that this would be one row of the 2D array, right? -1 and -1. So we're not going to store -1 -1 like this. It should be a 1D array. So we'll put this in brackets like this. So there would be two square brackets, and we're spending -1, and this shouldn't be -1. This should be the current value of I plus 1, which means when I would be 0, so this would be 1. When I would be 1, this would be 2. When I would be 18, this would be 90, so on and so forth. And then in the last, for the last index, we'll say linked list for the last row, we'll say linked list is equal to -1, -1 like this, and this will be the whole idea. And here we have to, or we can, yeah, this is fine. Or we can also do it this way. We can separate out the column number to be -1, which is the first one is data, or the second one would be the next pointer. So we can also set this next pointer to -1 like this. So this is fine, or the approach that I've written is also completely fine, just like we were doing above. Now moving to part B, they're saying the procedure insert data takes 5 positive integers as integers from the user and insert these into a linked list. Each item is inserted at the front of the linked list. The table shows the steps. Okay, so when we're adding the values at the head of the linked list, that means that the start pointer will be changing here and there. So let's say this was the code that we have. Okay, so now if I add a value at the head, that doesn't mean I'm adding at index 0. Let's say the start pointer is at index 0 right now, or the first node is pointing to index 0 right now. Okay, so if I add a new value, let's say the new value will go into the next available space in my array, which could be index 5, and let's say the data value could be 38, and this is going to be the new head value, which means that the current head is right now at index 0. So what we'll do is we'll point the first node here, right? First node will now, and then from this first node, where do we go to? We go to the current head, which will technically become the previous head. So this would go to index 0 now. And what will happen now? 38 becomes the first node. So from 38 we go to next, we go to row 0, and now 100 is the second element. Initially it was the first. Let's say I have to add another element at the front of the queue, at the head of the queue. So again, let's say I have the value 12, and then First of all, I'm going to set the next pointer to the current head pointer, which is set to 5. And then I'm going to update the first node to point to the new node. So now the linked list will start from node 6. I'll read the value of 12 and then it will point to 5, which was the previous head. This is what we have to do. Okay, in order to do this question, first we'll again visualize so we understand what we have to do. So they're saying that we'll be inserting data at the head of the queue. So as we discussed how we're going to add the head, we'll first just pick the value and we'll add it into the current index that is pointed to by first empty. Then we are going to make the head, make its next pointer point to the current head, which is, let's say right now 0, and then this will also become the first node. So now what will happen is that our queue is, the linked list is going to start from index 4. Then the next pointer would be 100, which was initially the start. Okay, so what do we do now? We have to first start with the value. Let's say this was the first node here initially. And then we are saying that this has to be the new node. So let's have the value 500 and maybe this was 5. So first thing that we have to do is we have to get the next value that is going to be after it. So we'll read this value and we'll go to this index and let's call it the maybe next free space, right? Next free, which means that the next value is going to be stored here, and right now we're going to store a value here. Technically this should be -1. Okay, we did this. Then what we're going to do is we're going to store some value here, which would be, let's say 500. And then once we stored the value, we're going to say that the first node will also point to the same index as the first empty. So I'll say first node becomes equal to the first empty, which means now first node will also point to this node at index 4, right? And before we had overwritten the value of the first empty, what we did was we simply got the next free value from this current value, and now this next free should become the first empty value because this is where we're going to insert the new value, right? These are the steps that we have to do. So let's write down the code for this. This is the insert data function. So we have to again keep on visualizing the data in order to make it work. So this would be defined insert data, and we'll global the linked list, the first node and the first empty, and we should write them above like this. This would be our main program. Okay, so with this done, okay, so first of all, I am going to loop 5 times because it says that you have to take 5 positive integers as input from the user. So we'll say for I in range 5, and then we are going to start inserting the values. Okay, so they have talked about the linked list state. So each item inserted at the front of the linked list, the table shows the steps. Not null, insert the data in the index pointed by first empty, change the pointer to the index pointed to by first node, change the values of first node and first empty. So we have already discussed this. And then if the linked list is full, then we'll do end of procedure. Any node that is at the end of the linked list has a pointer of -1. So first of all, we have to check if there is actually any value in the linked list, and that would only be the case when the value of first empty is not equal to -1. Okay, then that means that we can actually add a value, otherwise there is no space, right? Otherwise first empty would not be pointing to -1. So we check if first empty is not equal to -1. If that is the case, now like we discussed, we have to get the next free element first. Okay, because we are going to be storing the values at the current empty value. So this is the first empty right now. This is the value. This node was free. So since this node is going to get consumed by a value now, we have to get the next free value, which would be stored at the next point. In this case, it would be 5. Then in this case, it would be 6. So I'll say next free would be equal to the value stored at the linked list current first empty. Okay, first empty means this row number 4, And since I need to get this next value, this is stored at column number 2. So column number 1 basically from 0 and 1. Okay, once this done, now I can store the value of the data item here. That will ask the user to input. So linked list current first empty, which is again first empty is the current node that we're standing at. The new node first empty index 0 is equal to int input enter data value, and we should just put this in a new line maybe for ease, and this would be data like this, and then we get the data value here, right? Now the next thing we have to do is that whatever the current node would be, this should become the first node as well. So let's say initially the first node was this node and with values 100. So now we have to make this the head node, because they're saying that we have to add these into the start of the linked list. So I'll just say that first node, that linked list current first empty next value. So first node will now point here. Whatever the value of the first node was, let's say it was initially 0, now first node is stored as the next pointer here, which means that the current value 500, the next pointer has become 0, so that it will point to this 0 now, right? Okay, now we have to update the value of first node. So what will the first node become equal to? First node will become equal to this first empty, this index that we were at, which is index 4, the value 500 0. So first node should now store the same value as the first empty, and then we had set this to next free. This was the next free value, but next free is not a global variable. We need to update the global variable. So now the next empty value node that we have would be this one. So first empty would next time would thus become the next free value. So we'll say that the first empty is equal to the next free. What was next free? Next free was basically just pointing to the current value that is now available for the linked list to add into. So again, what did we do? Whatever the head of the queue was, the linked list was, let's say it was 44 and 4, maybe at index 1. So we added a new value in the linked list. We set its next pointer to the current first node or to the current head of the linked list, and then we changed the head of the linked list to the new value that we added. And meanwhile, we simply updated the value of the next free, which is going to be the next available space now, since this space is not going to be available anymore. And that's all that we did. So this is your insert data function. So in part C, we have to now define output linked list, which is going to do basically output all the nodes in the linked list. So what will happen now is, let's say again this was our first node. Okay, let's say this was our first node as we updated. So we start from 500, next is 0, then we go to 100, then next is 2, we go to 60, next is 3, then we have 99, it goes to index maybe 1, and just for now we're going to end the linked list as at 1. So after 99 we go to 1, and at 44 it becomes -1. Okay, so how do we output the linked list? The linked list, we're supposed to output the linked list until the value of the next pointer becomes equal to -1. As long as that is not the case, we will keep on printing the values of the column 0. This is the data value that we're looking at, right? So let's start. We'll start from the current, let's call it the current node, and current is equal to the first node that we have. So the first node is right now pointing to index 4. So we start from here, and then we'll just keep on going to the next index, next pointer values until we get -1, which would be this case. Okay, so we'll say while the current is not equal to -1, we simply have to just print the values at the current pointer. So print linked list current node index 0. Again, what does it mean? So we start from the first node. This is column 0 value. It will print 500. Now I have to go to the next value, which is stored here at column 1. So I'll say current should now get updated to linked list current column 1. So this will now read the next pointer, which means I was at this node. Now the next pointer is stored at column 1. So the value is here is 0. So I go to 0 now. Okay. I update the value. So I get the value 100 now. Okay. So 100 is again not equal to -1. So -1. Yes. So we check here. The next value is 0. So this next value is 0. So we go there, we print the value of 100, and then we get the next value. So the next value at this node was 2. So we go and we check, is 2 not equal to -1? No. So we keep on doing this until we reach -1, and then the loop will end. So this is the basic idea of the program. So there was one issue here. We were trying to access the index 19 column 0. So that wouldn't work because we had only appended into 18 values of the linked list, right? 19 values basically. And we had initially set it to empty array. So when we're using the append function, then to keep it consistent, we should just use append here as well. Also, if we don't use append, what will happen is we are trying to access an index that does not even exist right now. So if you want to do it this way, then you first have to set the size of the linked list or the queue or the array stack, whatever. So for I in range, and for that you need to set the columns and rows. So you'll say for, let's say, column in range 2, and then for row in range 20. If you do it this way, if you set the size initially, only then you can access it directly, and then you don't need the append function here because the linked list is not empty anymore, right? But if it is initially empty, then we have to use the append function. So that is what we have to do here as well. So we'll just write dot append like this. Then the question said that we had to test the program. So we have 5, 1, 2, 3, 8. So I'll run the program and I'll write 5, 1, 2, 3, 8. And it prints the value 83215. Why? Because we are adding the values at the head of the linked list. So whatever the new value gets added, it will become the head of the linked list. So the last value to get added would be the first head, then second, then third, then fourth, then fifth, etc. So this is working fine. Then they're saying the procedure remove data removes a node from the linked list. The procedure takes the data item to be removed from the linked list as a parameter. It checks each node starting from the first node, and then we have to remove this. Now before we start the part which asks us to write code to delete the node, we have to figure out how do we actually delete it in the linked list. So we have the data at column 0, and we have the data at column 1 for the next pointer, and we were using the array here. So the idea would be that, let's say you want to delete the value from the head. Okay, so the first node is pointing to index 1, which is at 40, and then 40 is pointing to 2, 2 is 10, and then 10 is pointing to 0, 0 is 20, and then 20 is pointing to 4, and then at 4 we have -1. So this would be the end of linked list. So we'll get a linked list in this format. Now if you want to delete the values, there would be two scenarios. First scenario would be that you want to delete the value from the head, or you want to delete value from elsewhere, or from delete nth node like this. Okay, so how do we do this now? So if you want to delete value, what to do is, first we'll go to the wherever the first node is, and first node is pointing to index 2. So index 2 we have 10. So essentially what we have to do is, if the first node is pointing here, we need to first make sure that first node goes to the next head, which is right now 10, and then we get rid of the value of 40, right? This is what we have to do. So these would be the steps. Similarly, if we visualize it, if I have some values, so I have 3 values. Now I want to remove the value from the head. So if I say delete head, If I say delete head now, so what will happen is that the first value is gone, right? So now head is pointing to 55. If I delete 55, so head will now point to 90. If I say delete head, so it now points to 90. So same logic. Now this is what we have to implement here first most. This would be the first case where we are deleting the value from the head of the linked list. Okay, what we'll also have to do is that we'll have to update the pointers as well. So when we delete this value of 40 here, so the next pointer of 40 uh, should go in order. So let's say if I delete the value of 1, node 1, so the next pointer, since we are at index 1, the next pointer should become 2. It's already coincidentally 2. Let's say if I delete the node 3, so the next pointer should become 4. If I delete node 4, the next pointer should become 5. So we'll always go in sequential order because that is how we initialize the linked list. Okay, this is the first case. Then what if I want to delete some other node? Maybe I want to delete 20. Now in this case, I would need to keep track of the current node and the previous node. So why is that? So let's say I want to get rid of 20. So this would be the previous node and this would be or you can call it, this would be the first node, this would be the second node. So what will happen is if I want to remove 20, what I'll have to do is I'll basically end up joining 10 with 80, right? So if we again visualize it, so I add the value at the tail, then we have 80 like this, and then 23. Okay, now if I want to delete a specific value, delete at index maybe 1. So if I want to get rid of this 90 here, if I say delete at index, I get this value, I remove this, and then 90 and 80 will get joined together. So what will happen is I need two pointers because I know 10 is pointing to 20 and I know 20 is pointing to 80. So when I remove this value of 20 here, I would want to make sure that I end up first pointing the next pointer of first to the next pointer of the second value. So the first of next pointer will get assigned the value of the second next pointer, the value of the second node's next pointer. So what is the next pointer to 20? It's going to be 80. Wherever 80 is stored, now first next will be pointing here. This is the whole idea, right? So once we have understood the problem, now we can move forward. And also every time we delete the value, we also have to set the first empty bit, right? Because let's say if this value is gone, we set it to -1. So now first empty should also point here because now this is where we can insert the next value in the array. Okay, keeping this all in mind, we'll go back to PyCharm and we'll try to solve this now. Question number is 3. Okay, so we'll now write the function for remove data, the procedure. So we had the insert data, we had the output linked lists. Now we are writing define remove data and we're passing in the actual node that we want to remove. So there would be some value to the node. Let's call it node to remove like this. Okay, and again, what was the node? Our node is essentially just a value that we're passing into, and it's going to be an integer value. Okay, and then we have the 2D array of linked list here, so we're following that. Okay, now remove data. First of all, they're saying that it takes the data in the procedure to be removed, and then it checks each node in the linked list, starting with the first node until it finds the nodes to be until it finds the node to be removed. So we'll do as the question says. We'll start from the very first node and we'll go through all of the nodes one by one. Okay, so we'll global everything that we need here. Then we check. First of all, we have to check that if we're removing the value from the head or not. Okay, so if the value of linked list first node current data, if it is equal to the node to remove. Okay, what does it mean? So let's say if I want to remove the value, let's say this is the first node is 500 right now, and I want to remove the value 500. Since 500 is essentially the first node, again ADT's linked list are non-linear, so it would simply mean that we are looking at the linked list in this way. So it would be 500. We start with 500, then we go to index 0, we have 100. Then it says go to index 2, so we go to index 2, we have 60. Then it says go to index 3, we have 99. And it says go to index 1, it says 44, like this. And then the next pointer would be -1. In this case, we'll stop here, end of linked list. Right? So this is how it would look like. Okay, so we're checking if the first node that you want to remove is actually, if the node to remove is actually the first node in the linked list. Just like we discussed, what we have to do now, since we are going to remove this, first of all you have to make sure that 500 is next pointing to 100. So now 100 needs to become the first node, right, at index 0. So we have to do this. Now in order to do this, we will have to assign the first empty. So we have to change the values of first empty, and we have to change the values of the pointers as well. So new first empty, in fact, first empty. Okay, let's create a new variable. Let's call it the new head of the linked list. New first. Okay, they called it first node, so new first node. Okay, so the new first node would now be add linked list first node next. Now what does it mean? So the current first node was set to 500. So what is at its next pointer? It's 0. So now 0th value would be the new first node. So we make that happen, right? Then the new first empty. So since we are going to get rid of this value now, this would become an empty value, right? And that is what we're doing. We're saying that wherever the first empty was, we're going to go to that next value. So let's say our first empty was pointing here. This is where our first empty was pointing to. So now we just have to make sure that when we delete this value, it should now point to the next empty, which would be at index 6. Okay, so we'll say, or we don't even need this line, we can just write. So first empty was right now pointing here. So now it should, the first node that we're going to delete, this node should now point to this first empty. Okay, so this next pointer from 0, it should change to 5, because this value is going to get empty now, and we'll change the value to -1. So we can get rid of this. We can write linked list first node index 0 is equal to 1 is equal to first empty. So what does it mean? I'm saying that whatever the first node was, which was 500, go to the next pointer of first node and put the value first empty there. So wherever the first empty is pointing to, now the next pointer of our current head will point to that. Okay, so it's not going to point to 100 anymore. 500 would instead point to some other value which is not part of the linked list. Okay, with this done, now we just need to change the first empty, and we need to change the first node. Okay, now first empty would become first node, and then first node would become the new first node. Okay, what did we do here? So first empty was initially pointing here, right? But now first empty has changed because this value would be deleted, the value at the head. So 500 will be deleted now. So what I'm saying here is that the first node, the current value would be copied into first empty, which means since we are deleting 500, where was 500 stored? It was stored on index 4. Right? So first empty should now point to index 4. Why? Because we are essentially deleting this value, which means this node is now going to be available. Make sense? Okay. So we do this, and then in the next part, we are going to set a new first node. Okay. So what is going to be the new first node? Again, 500 was pointing to 100. So we had already copied this into the new first node. We said wherever the current node is pointing to, current head node is pointing to, that would be the new first node. So that's what we're doing. 500 was pointing to index 5. So we go to this was pointing to, in fact, initially it was pointing to 0, so we went to 0 and said this would be the new head node, and then we changed its pointer to 5 because it's going to be empty now. So this is what we're doing here. The value of the new first node will now become the pointer to the first node because this is going to be the head of the new linked list. So essentially we have deleted 500 from here. This is when the value was to be removed from the head. If you understand this, then the remaining part is the same. So else if that is not the case, okay, and now we're going to check. So else if that is not the case, we are going to start from the first node and we'll make our way through the whole linked list. So let's say I want to delete 99 now. First of all, I need to find 99. So I'll start from 100, wherever the first node is. Then I'll go to the next node, then I'll go to the next node until I end up finding the value that I'm looking for. Okay, so we'll say, let's call it current node is equal to first node, which means we are going to start from the first node, which would be stored at index 0, which is 100 right now. Okay, then we're going to say that the previous node will be set to -1, or you can just call it first node. We already have first node. Okay, let's call it current and previous. Yes, current and previous is fine. Or you could have used the names first node and second node, but first node is already being used, so we cannot reuse it. I'm setting it to -1, just making sure that it is initially null. Okay, now why do we need two pointers? Because like we discussed, if I want to get rid of this 99, I need to make sure that the next of 60 is pointing to the next of 99, which is technically 44, and only then we can remove the value of 99. Okay, so then we will start and we'll say while the node that you want to remove is not equal to the value at the current node pointer. Okay, so how do we get that? So we'll write linked list, we'll write current node index 0. Why index 0? Because in the linked list, index 0, the column 0 contains the data values and column 1 contains the next pointers. So that is what we're doing here. You're saying okay, so we're saying while the node to remove is not equal to the linked list current node 0, which simply means that the value that you want to remove, as long as they do not match. Let's say I want to delete 99, so I'm starting from the first node, which is set to 100, and I'm looking for 99. Is it equal to 99? No, so I'll go to index 2. Is it equal to 99? No, so I'll go to index 3. Is it equal to 99? Yes. So this is what the while loop would do. Either this, as long as that is not the case, or we end up going to the end of linked list. That would happen if the value does not exist. So let's say if I'm asking you to delete 2 does not exist in the linked list, right? So there would come a point where we would have seen all the values from 44, then the next pointer, the current pointer would have become -1. We would have reached these null values. So then the loop should also stop because the value does not exist in the array. So this becomes and current node is not equal to -1. So this is just to make sure that the value of current node is present. If it is null, then we stop. Okay. All right. Now in the next part, this loop will make sure that we either end up finding the value or the value does not exist in the linked list. Okay, what do we have to do every time? So if we start from 100, this would be the current node and there wouldn't be any previous node. Then when we go to 960, so 60 becomes the current node and 100 becomes the previous node, right? Then when I go to 99, then 99 becomes the current node and 60 becomes the previous node, and when I go to 44, 44 becomes the current and 99 becomes the previous. So this is what we have to do. So what we're going to say here is that whatever value of the previous node is, it will become the current value every time. And then what will happen to the current node? Will simply go to the next value. So look at this. If this is our current node right now, if we're standing at 60, how do we go to the next value? We'll go to 60 and we'll go to the column 1 value, which is the next pointer, right? So then it will take us to the next value. And what will happen to the previous value? So previous value would simply become the current value, just like we did here. So currently this is the previous value and this is the current value. So what will happen next time? Your current value should become the previous values. And we just do it by copying the value of the current node into the previous node. And then we're saying that the current node would go to the next value, which would be at linked list current node index 1, which is essentially saying that go to next pointer of current node, like this. All right. Then we move forward. So this will allow us to get the current node that we are looking for. Okay, so when the while loop ends, there would be two possibilities. So the two possibilities would be that either we found the node, either we found the target node to delete, or the node does not exist in linked list. Okay, so the while loop would end. Now once the while loop would end, we have to update the pointers. Let's say we found 99 here that we want to delete. Now what we have to do is we have to just update the pointers here. So what we'll do, again, like we discussed, linked list previous node next pointer should now point to linked list current node next pointer. What is this doing? So if I want to delete, let's say if I want to delete 99, so current node is 99, previous is 60. So I'm simply saying here is that the next of 60 should now point to 44. How do we get 44? 44 is basically the next of 99. So what I'll say here is that store value of 99.next into 60.next, right? And now in order to do this, what we'll do is we'll simply write this code. We're saying get the value of the current node's next pointer and store it in the value. Okay, so we get the value of the current node and then we store it in the next value of the previous node. Again, what did we do? We're storing the value of the next of 99, which is 44, into the next of 60. So then that means this connection would technically be gone, because 60 is not pointing to 99 anymore. So 99 would kind of get deleted from the linked list. Now, in order to delete the node, we have to set it to -1 as well. So we have to set linked list current pointer data value to -1. This should be current node, okay. So the question said that whenever the value would be deleted, you have to set it to -1. So we are setting the data value to -1, and we should be doing this here as well. When we delete the value from the first node, and we set it to -1 as well, okay, in the previous part. Okay, with this, the value is deleted, node deleted. Now we just need to update its pointers. Okay, so the node is gone. So this 99 here is technically deleted now, but we need to update its pointer, next pointer. Okay, so what should happen to the next pointer? Now first empty should point to this current node, right? Because this is empty now, so that's what we have to do. So we'll say that linked list current node next pointer should now be pointing to first empty. So what will happen is 99 current node was pointing to, my bad, first empty was pointing to, let's say here, or let's say first empty was pointing to here. So I'm saying that 99 next, which was pointing to index 1, shouldn't point to index 1 anymore. It should point to where first empty is stored. First empty is stored at 5, like this. Okay, the reason, or it should be technically at 4, assuming the first empty is correct. So now what it means that the next value of this node, so this 99 has become -1, and then the next pointer goes to index 4, right? So this is what we have done. And in the last part, so first empty is done, and now first empty should now become equal to current node. What does this mean? So the current node that we have right now, which is 99, we are saying that first empty should now get its value. So because we have deleted this 99 here, right? We deleted this 99, we set it to -1. Now this node is entirely free. So we are going to set the value of first empty here to the current node. And with this, the deletion would be done.